Welcome back to Chem with Kess, where we're bringing everything all together. So it is important that you understand both of the charts that I have above. You have the one on the left that I told you should kind of memorize these areas because it will be helpful in some instances. And the other one on the right, it tells you about when something is upfield or downfield, which we discuss that upfield is away from electronegative atoms compared to downfield, it is towards more electronegative atoms, being oxygen, double bonds, triple bonds, oxygens, nitrogens, sulfurs, all of those items in nature. So when I give you two spectrums, as you can see below, one went from -1 to 12 and the other one went from 0 to 11. The basic scale is 0 to 12. Focus in on that. Now I gave you one for the 4-ethyl benzaldehyde, which I already participated in the symmetry. You can go through and still do the total number of carbons and check how many H-NMR signals you'll have, which in this case I already wrote for you is 5. So just have your safe practices that I've already provided to you. And then when it comes down to the biggest part, we did the multiplicity in order to now match it with what is labeled. Now, every so often, they may not have these labeled symbols for you, each one of the multiplicity signals. Sometimes you'll have to actually look at these dots in order to tell that it's a triplet. So I put those items in there to make it just a little bit simpler for matching purposes. So now that you have yours on the left, let's go ahead and just put the letters there, and then we'll talk about the downfield and upfield. So at number 10, that would be A. At number 7 and 8, we have two doublets. So I'm just going to do something which sometimes instructors allow you to do this. I'm just going to couple them and say B and C. But in a second, we're going to actually identify which is which. The quartet must be letter D, and the triplet has to be E. Now let's make this make sense. So E is a CH3, and CH3 should come closer to 0. Look at this. Everything is matching. D is a CH2, which should be somewhere between 1.5. Now, pay attention. D is connected to a benzene ring. So even though we may expect it right around 1, why is it all the way almost close to 3? It's because the double bond on the benzene ring has an effect that forces it downfield, and that's why it's located in the position that it's in. That's all you really need to know about downfield and upfield. You're always determining that based on the structure you have. A is an aldehyde. I told you aldehydes would show up between really 9 and 10 or 9 and 11, and boom, there it is. There's no lies. So you really, if you didn't believe me and you went straight towards the end of the video, please go back and watch all the previous ones to make it make sense. And then when it becomes C and B. Now these two, they're both in the aromatic region, which we said was around the 6.5 to 8.5, so it's found there. But what's the difference between C and B? When I look at the neighboring carbons, they're both similar, but what I really want to pay attention to is the groups it's connected to. C is connected to alkyl chain, versus B is on the side more with the carbonyl. So the carbonyl is stronger, so I'm actually going to expect B to be more downfield because it's more related to the carbonyl, and C more upfield. That's all. That's what we were fighting to accomplish. So now let's do the same thing with 2-pentadone. Again, you can go through and count your total number of carbons, which is 5 and 4. And I've already given you the signal, so let's go ahead and label them. So again, you see how they start to like smush them even tighter? Those are when they'll be just a little bit harder, and sometimes they will go ahead and label these for you. to make life a little bit easier. So again, you see how tight this is? It's not a big deal. Now let's use what we know. A is a singlet. A is a CH3. I'm expecting the CH3 to be close to 0, but there's no singlet there. The singlet is all the way at number 2, which makes sense since A is directly next to the carbonyl. So I'm expecting this one to be A. Now, B is a triplet. Well, I have 2 triplets in this case. B is also a CH2. This CH2 is normally located here, so you would just assume that it would be this triplet. But remember, it is still connected to that carbonyl, which will force it more downfield, which actually makes B your last triplet located closer to 3. Then when you have C, very simplistic, it's a sextet, and that's the one that has multiple peaks right here, and it kind of makes a little bit more sense too. C is also a CH2, but it's further away from the carbonyl, which means I expect it to be more upfield, because upfield is the side that does not deal with too much electronegativity. So that's why C is there. And then for D, that's your last true triplet. So when you're looking at the 2 triplets and you're trying to distinguish them apart, it's really the carbonyl that plays the biggest difference. Let me know what you think.